Everyone, I'm just waiting to see if everybody else is joining at the moment, but tonight we're going to talk about the electrical vehicle charge point installations, and based on the OZEV report, the last report they did on the electric vehicle charging through the grant system. So we're going to cover that today in the presentation and cover the top 10 tips that we pulled out of that report, and we'll run through some of the aspects of the report and some of the example photographs that were included in the report. So we're going to cover that, and as always, you'll get a CPD sent out to you after the webinar. Probably tomorrow will be sent out. You get to keep updated on the CPD with everything in there. So as we're going to start, I'm Frank Bertie. I'm the Chief Technical Officer of NAPIT, and part of what I do is sit on JPL 64, which is the committee responsible for the wiring regulations, so BS 7671, and also deputy chair of subcommittee A, which covers verification. So the OZEV are the Office for Zero Emission Vehicles, and they carry out an audit report because they've got grants based on the EV charge points, and with the need for those grants, they've got to do audits to make sure the government are getting the best benefits for the money they provide for them. So part of the process is carrying out audits. One has been carried out previous to this one, and this is the second one. And as it says there, these ones were carried out between November 2020 and February 21. And there was 371 audits carried out on the electric vehicle charge points. The audits were based on the condition report, electrical installation condition reports, and part of the findings of the audit report are based on the EICR style of reporting. And this is, we've all thought was a flawed approach to the EV OZEV report on the EV charge points. It was to see if they meet the full requirements of 7671 and under the terms of OZEV and the IET Code of Practice. But as we all know, EV charge points are brand new installations, and they must meet with fully with the requirements of 7671. And some recommendation report are pertinent to the installation of EV charge points. And what we've done within this presentation, we've summarised the findings within the EV charge point audit, and we created the top 10 tips for EV charge points, so people can look at those to see what the aspects of the audit report was, and helps towards your CPD within the electrical installations. So part of the audit report was carried out. There was percentage scoring for the full inspection, and there was 4 categories for both the 2019 report and the 2021 report. So the 2019 report had 615 audits, the 2021 had 370 audits. And within the table, this is an extract from the report, and it shows the differences between the 19 report and the 2021 report, and shows the differences of the category codings within there, and to see what the differences were. So the overall score at the top of the table shows the dangerous, potentially dangerous, improvement recommended, further inspection, and satisfactory. And it went through each of these reports and gave a listing of all the different aspects of it, and it shows the differences between each part of the report, between the different reports from 19 and from 21. And the overall score showed here, and you can see there's a difference in the dangerous ones, which was 0.1% going up. Potentially dangerous was a reduction. Improvement recommended, there was a reduction in that. Further inspection was a slight increase, and satisfactory, there was an increase as well. So that was better installations. So the key recommendations for the assessors, they were asked to look at when they went out carrying out these audits, was any outstanding rectifications were made to the installer and were followed up and resolved in a timely manner on this. And it covered all these points. It covered earthing, RCD protection, design of the cabling, The correct issuing of the paperwork for all aspects from certification to notification, and for the DNO information as well. Checking of the main equipotential bonding, labelling, any water ingress, the height of the socket outlets, and of the display screens of the EV charge points. And there was a gap in the notification process. So when you have to notify within England and Wales any work on behalf of the building regulations as part of the competent person scheme, there's no separate requirement for listing EV charge points. So they're listed under the new circuit, and that should be notified under there. So there's no way we could track how many EV charge points were actually carried out, except for under the OZ notifications where grants were applied for. And the key recommendations for the EV installers was checking, is the existing installation earthing fit for purpose? Does it relate to TT systems? Are the RCDs in compliance with 76711 2018? And that was obviously at the time of the audits, that was to Amendment 1 to 2020, which was the change to the EV installation. Looking at the cable design, making sure notifications are completed and where the required certification is issued to OZ, to the householders and to building control. And the electrical installation and distribution equipment is satisfactory condition before the EV charge point was undertaken. Revisions are made in report to issues where the condition of the newly installed consumer unit, the main equipotential bonding, non-combustible consumer units must be installed if new CUs are fitted as new or they're going to be replaced. All the correct labelling is in place to cover the EV charge point and any associated equipment. And consideration is needed for water ingress with the EV charge points, cabling as it exits the building, things like that. And assessment of adequacy of supply and how current transformers should be installed. And the height of the socket outlet and display screens in line with the IET code of practice. And the measurements are between 1.2 and 1.4 above the ground. And for the display system and for the socket outlets, between 0.75 and 1.2 meters. An extract of Table 1 for the overall 2021 audits results. And of the 66 of the 370 completed audits were found to have dangerous C1 or potentially dangerous C2 issues in one or more categories. And as I said, the auditors used the EICR reference methods codings, which because of new installations would be non-compliant with BS 7671. And this amounted to 7.8% of the installations, which is a 5.2 improvement on the 23% EICR classification codes and C1, C2s from the 2019 audit. So there has been an improvement. And this is a table, again, shows you what we're looking at, where the aspects were. So the dangerous ones were new installations, existing equipment, charge points, and its overall score was 8 dangerous installations were found. Potentially dangerous, existing installations again was the most point on here. Charge point installations at 35 and overall 58 potentially dangerous. Improvement recommended, again going through them all. Existing installations had a few of those, existing distribution equipment. The charge point itself had quite a few instances, and the cabling, so 239 improvement actions were required on this. Further inspection was quite low, and fully satisfactory was obviously better in there on that side of it. So what we're going to start looking at is the top 10 tips. Now within the document we've provided, all these checks and tips are explored in full. I've got some of the extracts within there and we'll run through some of them. So whenever new work is proposed on an existing installation, verification must be carried out prior to that work to ensure that the work can safely be carried out. And we're looking at the installation loading would not be exceeded by the installation of the charge point. The earth and bonded conductors are in place and are suitable for the new installation. The service equipment has no visible issues that would affect the new installation. The consumer unit is suitable for the operation to include the new works. And this would entail an inspection testing of parts of the electrical installation, as well as load assessment to establish if a load management system wouldn't be needed to prevent the installation being overloaded. So that's going to be one of the prime examples of where a load management system could be installed if the installation is going to be overloaded. So just check with the client if there's been a previous EIC or an EICR for the premises, and that will give you an indication of what the status of the installation is. So any problems that would be highlighted on any of these two, either certificate or the report, would allow you to see what the problems are. If neither of these are available, then the full inspection and testing of the installation may be required in the form of the EICR to establish if there's any issues with the installation. And it's recommended that the existing installation within the premises prior to an EV installation being involved. So you're looking at that before you start looking at installing an electric vehicle charge point. If the EICR is satisfactory, then EV charge point can proceed. If any C1s, C2s or FI codes are recorded, they must be subject to corrective action before the EV charge point can be installed. The inspection test will determine if the installation is adequate for an EV charge point, and this includes an assessment of the distribution equipment and the service head, service cables, etc. And any issues found with the distribution equipment or service head should be reported to the electrical supplier or DNO, and the work should not continue until the work has been corrected for the EV charge point to be installed. And where there's inaccuracies with the DNO supplies equipment, the person that's ordering the work should be informed to contact the appropriate authority to carry out the rectification work. And the symbols used on these to record these issues on the EICR for Amendment 2, as we're now into that one, would be an X. But obviously the previous audits were still based on the previous, where it would be highlighted as a C1, C2, C3 or an FI on any DNO supplies equipment. And this is just an example of where the categories are, where the DNO is involved in the green, and the purple colour is the supplier's equipment. Then the consumer's equipment is in the sort of the mauve colour, and that just highlights where things are and who's responsible for each part of the equipment. We did have some examples of service heads which were damaged or exposed live parts that were observed during the audits. And while this does not form part of the EV installer's work, these issues should be reported for rectification by the DNO, and that is issuing to the client to get the issues corrected in there. And a couple of these examples are damaged service heads. So this one here, we got tape over the neutral connections on here, damaged crack units to the edge of the service cutout. These are all things that should be highlighted and put forward to the client to get rectified by the DNO or supplier. These are some other ones. So we've got some exposed live conductors, and you've got some exposed terminals at the top of the service heads here as well. These are the type of things that come across in the audits, and as installers, you're going to come across these type of things as well. So they should be reported to the client, and they will report them to the DNO or supplier to get the work corrected, so it's safe for the installation. And the second tip is supply earthing. So looking at earthing is an important aspect of electrical safety, and with electric vehicle charge points, it's exactly the same process. We need to have satisfactory earthing for safe installation of electrical work on EV charge points. And BS 7671 section 722 provides the details for the correct means of earthing for EV charge points. The options for protecting against electric shock are using EVC CP with inbuilt device that disconnects the charge point from live conductors and supply protective earthing, as in regulation 543.3.3.101 brackets 2. Convert EV charge point to a TT system, install one or more earth electrodes, or install a protective neutral fault detection device to make sure in the fault of open pen conductors the EV installation is disconnected from the source. So TNCS premises, the fundamental requirements of the electricity safety, quality and continuity regulations, ESQCR for short, have prohibited the connection of TNCS systems to network of leisure accommodation, including caravans, and the same concerns exist with EV charging due to dangers associated with the PM system under fault conditions when we lose the pen conductor. TNS premises, the TNS system does have some restrictions as well, and the distributor's earthing system must be verified. For TNS systems, consideration needs to be considered where the TNS system hasn't been converted to TNCS as part of any network upgrades and repairs. And it's difficult to make sure you could fully cover that because it's difficult to confirm back to the source that it's still a TNS system unless the installation has got its own transformer. So TNS systems are for EV charge points and for other things should be treated as TNCS for design purposes, because we can't confirm the TNS system back to the source unless the distributor or supplier can confirm that, and it's very difficult for them to do it because as repairs are carried out, they've got prepared the cables from TNS to TNCS cables for installation purposes. TT premises, the adequacy of the TT system must be checked before any EVCP is installed. Making the whole installation in the TT has an advantage of no possibility of simultaneous contact between exposed and extraneous conductor parts of the different earthing systems. But we need to consider with TT systems where there is neighbouring properties and is there simultaneous contact between those parts. Making the EV circuit itself a TT arrangement. This is carried out by divorcing the PME earthing system at the relevant point. This could be a dedicated EV consumer unit or at the charge point itself. And we've got one here where it's a dedicated EV consumer unit for the EV charge point itself, and it's got its own TT system of earthing. Next one we're looking at is the adequacy of supply. Now, electric vehicle charge points are high power electrical devices, and we need to make sure the EV charge point is installed and it won't overload the maximum supply to the premises. So what we need to do is assess the maximum demand for the EV charge point and the installation. So we're looking at the installation, what's the maximum demand for the existing installation. So once we've assessed that, we need to make allowance for diversity, which include the maximum anticipated load or the actual load of the installation. So this must be reviewed as the EV charge point can't take into account of diversity of the existing installation. So when we're looking at an EV charge point, it has to be notified to the DNO, and the different levels of notification required by the DNO. And the following table lists out what we're looking at. So if we're looking at less than 60 amps, but can't be connected, then notified to the DNO. So you've got the issue. So you've got 28 days to issue to the ENA form, which is available from the ENA website, to notify the DNO that you have installed an EV charge point. If it's between 60 and 100 amps, it must be applied for connection before installation. So you're looking at the complete the form, issue it to the DNO. If it's over 100 amps, you must apply for connection, and the form must be completed and the DNO to check to see if any additional work as in upgrading supply for that installation. So when we look at installing EV charge points, you've got to look at the requirements of the notification to DNO. So to determine an installation using the Bertie, we're looking at the installation of the circuits of an example of a 10-way consumer unit. Got 4 spare ways. It's got a 40 amp Cooper unit, 2 32 amp ring circuits, a 16 amp immersion heater, and 2 6 amp lighting circuits. And once we go through the formula, we're looking at assessing the maximum demand, and we're looking at 76.8 amps existing load for the maximum demand installation. So if we're going to install a new EV charge point, we're looking at say 7 kilowatt point. We're looking at adding an additional 30 amps, 30.5 amps onto the installation. So that would take the installation over 100 amps. So we're looking at possibly the use of the load curtailment. So you're looking at a load management system to cover this and to make sure the EV charge point is only in use when the installation allows it. So that would allow the maximum demand in there to cover if you were using load management. But if you didn't use the load management, the rating of the consumer unit would be unacceptable, and you would require a DNO to assess the service intake equipment to see if it needed an upgrade. So with the example, you can see what you've got to look at to see what the maximum demand is and what needs to be determined for assessing an electrical installation for an EV charge point. And in this instance, when it goes over the maximum demand for the installation, the form would be sent to DNO. Item 4 is talking about RCD devices, so residual current devices. Within 7671, Section 72 has specific requirements for the regulations for RCD provision of EV charge points. And there's 3 ways to comply with the regulations regarding RCDs, and these are: install a charge point with a built-in 6 milliamp DC detecting device in conjunction with the Type A RCD. Install a Type B RCD electrical distribution point to serve a charge point. Install a separate DC residual current monitoring device in the supply to the charge point. And we have a label notice to indicate the RCD requirements for testing the test point every 6 months. And obviously, at the time of the audit, it didn't exist, but under Amendment 2 of the relaxation within domestic premises, these labels could be omitted if they're included within the certificate or the EICR, which the model forms and the NAPIT forms has that information included in the information for recipients. It shows the labels that have and the information that has to be provided with the labels. If they are omitted, the information is on the certificates. And we have an example of the general requirements for RCDs. So you're looking at your different type of RCDs and where you can install them, where they can be the hierarchy of the RCDs. So installing a Type A has got to be installed right back to the system. If you install Type Bs, it can be before Type A and all the different types on there. And at the time of the audits, some Type A RCDs may have been installed, but now we're looking at Amendment 2, it's all Type A's that will be installed for EV charge points. You can't install AC on any EV charge point. Number 5 is looking at the cable design. Now it's important looking at the cable design, what type of cable you're going to use for the installation, where they are. And with EV charge points, there was 4 common supply cables that we've used. We've got flat twin and earth, we've got steel or armoured, we've got the dedicated EV charge point cables with the built-in communication cables, and we've got the NY cable, which can be installed as well. That's just examples of the type of cables. More and more we are using the built EV cables with the built-in communications because it's one cable that can be installed. And areas to be mindful when we're installing supply cables are the glanding, which is important. It's correctly glanded to stop ingress in there. The bending radius of the cable, the installation of cables to service pipes to make sure they're not too close to them where it can cause damage or problems with them, and the regulations around installing cables in walls. So just an example of some cables in there. And external cables to the EV charge points. We're looking at greater amount of mechanical protection placed on the cables because of degradation from exposure to UV lights because they're outside all the time. And the 5 main cables used externally is the NYY polyvinyl chloride cable, steel armor cables, flat twin earth, dedicated type for EV charge points, and singles installed in conduit trunking. And it's just an example of an external charge point. External cables to EVCs, please. So mindful when we're installing external cables are water ingress, lack of or incorrect use of glands and shrouds, proximity to service cables, bending too tight a radius of the bend, and poor choice of cabling routes. There is some access to cables we've got to be mindful of, where people can be exiting buildings, things like that. And this is examples of non-compliant issues found during the audit. So we're looking at the incorrect siting of EV charge points, subjecting the cables to tripping and hazards to people using them. So there's a cable here, obviously, will come out the door, can't quite see it, but the cable went underneath the doorstep, in front of the doorstep, so people can't be tripping up on this, causing hazards. So we've got to be mindful of that. So we're looking at the incorrect glands or seal. Cable sheath not secured by the glands. This is another one here. So we've got the twin earth pulled through the cable. It's not secured. There's not any termination or seal in here. You've got the wrong. The sheath of the cable is not inside the gland here. As it comes through the grommet, there's a bit of tape around it. So it's all that the cable's been secured properly. So there's no strain in the termination. There's no ingress of water or moisture into the EV charge point. So presence of water, lack of sealing, proper sealing, fixing. So you got some here. You can see in the highlighted areas there's moisture in here, there's water ingress here, and this cable here is not correctly sealed. You've got the screws rusted, it's not been properly sealed or properly included for correct sealing when you try and fix against the surface. You've got rusting in here. So there's always these issues were picked up in the audit. Number 6 is certification and notification requirements. Now, the EV charge points are subject to a number of certification and notification requirements. And they must be completed, and the customer must be issued with these to meet the requirements of OZEV, the DNOs, building regulations, and obviously BS 7671. So alerting the DNO, obviously touched on earlier about the assessment of the installation. So on the table, the previous table showed where the installer of the EV charge point must determine at what point the application must be made to DNO and whether it's the installation is suitable for connection, or a DNO could be notified prior to or after the event of the EV charge point. And this is just an example of the form for the EV electric vehicle charge point, and also does cover heat pump installations as well, but it tells you information what should be done with it and can provide the information you need to notify the DNO before or after the installation of the EV charge point. And the electrical installation certificate, it has to be issued for an EV charge point. It's a new circuit, it's a new installation, so an electrical installation certificate must be issued for this, and has to be completed and signed and issued by to the person ordering the work by the EV installer, as per Chapter 64 of BS 7671. And building regulations compliance certificate for anyone carrying out the work in England and Wales. A notification is required for EV charge point, and as I said previously, is classed as a new circuit, so that must be notified to the local building control, and with the NAPIT you do it through the NAPIT portal and notified through that way. So the time has to be notified to the DNO within the timescale. Number 7 is main protective bonding, and 7671 includes all the requirements for protective bonding for extraneous conductor parts. And each EV charge point installation must be checked to make sure the protective bonding conductors are in place, they're installed and correctly connected to the main earthing terminal. So the extraneous conductor parts include the following: water pipes, gas pipes, other installation pipework and ducting, central heating systems, and any exposed metallic structural parts of the building. So we must make sure all these bonding connections are in place before we start installing the EV charge points. And this is just an example of where we have extraneous conductor parts that can be accessible to where the EV charge point is installed. Correct labelling is number 8, and EV charge point must be clearly labelled to allow easy identification of the circuit, of the equipment, and for safe isolation and safe operation of it. And it is simple to miss out these labels, but it will result in improvement actually being recorded on any audit and any assessment. So correct labelling of EV charge points must be carried out. Number 9 is the height of socket outlets and display screens. So the requirements of the height at which an EV socket outlet and display screens are installed, they're set out to avoid damage from vehicle bumpers and to ensure the accessibility for people using EV charge points. So the mounting heights are as follows: EV socket outlets should be installed between 0.7 and 1.2 meters off the ground, and display screens should be installed between 0.2 and 0.4 above the ground, so they're viewable for a person standing or sitting using the EV charge point. So these are listed in the IT Code of Practice and no longer listed in 7671. So that's where the requirements for these are listed, and OZEV reporting mechanism refers to the IT Code of Practice. And this is the document that is referred to in OZEV charge points. And this is just an example of where the charge points should be included, and this was referred to in the audit report as well. So that's where we're looking at the height of the sockets, height of the display units as well. So this is some of the examples of the non-compliant issues that are picked up during the audits. The socket outlet is too low, 0.4 meters. Socket outlet is too high, 0.9 meters. So we've got one here. They're blanked out, so the manufacturers of the charge points are not shown, but you can see this one's too low in this point here for access, and this other one, the socket outlet, was too high as well to get in there to access it and display in there as well. There could be some issues on access to plug in as well for some of the points, and potential damage to the cables, things like that. And some other examples where the risk of impact from sockets, where they've not been provided with protection to prevent that impact on there. So we've got some here. This socket at low level again may be subject to damage from this car going in here. On the right hand side has got exactly the same point. The car can come in contact with the socket outlet itself. And common issues found with the socket outlets where we've got existing consumer units that have been installed. Now we've got water ingress as an issue, heat damage at the circuit breaker, condition of the termination blocks, and missing labels, damaged cables, missing blanks. And an EV charge point must be in full compliance with 7671 and any part of the existing installation that can have a material effect on the EV charge point installation has to be considered for correction that can affect the EV charge points. When we're looking at installation, we must consider everything that must be corrected during that point. And we have some examples of issues with the consumer units that were found during OZEV audits. We're missing blanks on these empty holes in the tops of consumer units. And these are examples where you've got a missing blank here, and to the right hand side here. You can see the EV charts being identified, but it's in here and covered in there. And we've got a missing blank at the top of the charge point here as well. Another examples of the missed consumer units were thermal damage at the circuit breaker, damage to the circuit breaker, which we used with the cable as a buzz bar. So you see here, you see the browning of the circuit breaker here was either from a loose connection or poorly terminated connection. On the side here where the bit of cable has been used to extend the charge point, and you can see the cables sticking out the bottom of the breaker, and there's damage to the breaker as well here. What we're doing, we're still covering obviously Amendment 2 master classes throughout the country, and we've got one final event in Bristol on the 15th of November, and there's still some places available for that one. And we've got the topics covered in all the new books for the EV charge points within the on-site solution.